Good morning. My name is Syed Mohammed, and I will be presenting on a general purpose infusion pump. So, what is a general purpose infusion pump? A general purpose infusion pump is often used in healthcare centers and facilities to deliver medications, solutions, and other fluids from a solution bag to patients in a steady and controlled rate via an intravenous or subcutaneous means. It is used in most cases as it delivers the fluids to patients with high accuracy and precision. It has a low tolerance percentage of 3%. It also has a high range of volume that can be infused to patients, ranging from 0.1 milliliters to 9,999 milliliters. It has various settings which can also be adjusted by the users to allow them to infuse a certain amount of fluid at a certain rate into a patient, depending on the dosage required. It is also a safe medical device as it is equipped with detection and alarm systems to alert users of any irregularities. So, how does the infusion pump work? The infusion pump usually consists of several key components which all work together in order to function effectively and allow the fluids to be infused into the patients. The fluid is usually in a bag that acts as a reservoir. It is connected to an intravenous tube, also known as an IV tube, which is connected to the patient. There is a pumping mechanism which pumps the fluids into the patient at the rate set by the user. This slide here shows the key components of the infusion pump, which are namely the reservoir, the pumping mechanism, the user interface, the power supply, and the sensors and alarm systems. Firstly, let's talk about the reservoir. The reservoir is a bag filled with the required fluid that is to be administered to the patient. It is connected to an IV tube that goes through the pump and then into the patient. The reservoir is usually sterile and in order to prevent any possible contamination of the fluids. Secondly, let's talk about the pumping mechanism. There are two types of pumping mechanisms, the linear peristaltic pumping mechanism and the rotary peristaltic pumping mechanism. For the linear peristaltic pumping mechanism, it is a series of contractions and relaxations, similar to that of our digestive system. The IV tube is placed against the tubing guide. The finger-like discs will then compress and release the IV tube sequentially in order to allow the fluid to flow at a certain rate in a ripple or wave-like motion through the tube, as seen in the top photo on the right. As for the rotary peristaltic pumping mechanism, the IV tube is laid around the rollers and is mounted on a rotor as seen in the bottom photo on the right. As the rotor rotates, the IV tubing gets blocked and forces the fluid to flow. Depending on what rate is set by the user, the motor drive will control the rotor speed accordingly. The flow direction can also be reversed, allowing bidirectional fluid flow. This is done by changing the direction of rotation of the rotor. Third, we have the user interface. Users can set the infusion parameters such as the delivery rate and the volume to be infused to suit the patient's needs via this user interface. For delivery limits between 0.1 milliliters to 99.9 milliliters, the delivery rate can change from 0.1 milliliters per hour to 99.9 milliliters per hour. For delivery limits between 100 ml to 9,999 milliliters, the delivery rate can change from 100 ml per hour to 1,200 ml per hour. This user interface can also be used to monitor how much of the fluid has been infused into the patient to ensure that it is being delivered at the set rate. The settings can also be changed at any time throughout the infusion, depending on the patient's needs in different situations. It is also equipped with the alarm system to notify users to take immediate action when necessary. Lastly is the power supply and the sensor and alarm systems. For the power supply, it is actually a crucial component of the infusion pump. It ensures that the infusion pump is constantly running and does not stop at any point throughout the infusion. If the power supply is faulty or melted, the whole infusion pump would stop working and may result in the patient's health being threatened. As for the sensors and alarm systems, it tracks the delivery and flow of the liquid in order to ensure it is flowing at the set rate and is not overdosing the patient. It also detects any irregularities such as occlusion and air inline. Once these irregularities are detected, The alarm system will sound and alert the users to take the necessary actions immediately. So, what are the applications for the infusion pump? The infusion pump is used for many things, such as to administer medication, to infuse nutrients into a patient's body, and even blood transfusion. Some patients require a specific dosage of fluid medication to be infused into their body at a certain regulated rate. This is where the infusion pump comes in, as it has a high accuracy and the rate at which the fluid medication is administered into the patient can be adjusted based on the patient's needs. As for those patients who had just undergone a surgery, which impedes their ability to consume food, the infusion pump can provide them the nutrients via the IV tube to ensure their body gets the amount of nutrients required to help in the recovery. The infusion pump can also be used to help with blood transfusions. For patients who needs the blood to be infused into their body at a steady rate, the infusion pump is useful as it is very accurate and reduces the risk of pumping too much or too little blood into the patient. Now, on to the problem statement. The problem statement I have come up with is as shown here. In the medical field, the infusion in the medical field, the infusion pump is heavily relied on to deliver liquid medications to patients through intravenous or epidural routes at specified flows. However, despite it being used by most healthcare places, there are still several challenges that affect the efficiency and reliability of the medical device. So, what are the problems with the infusion pump that affects its efficiency and reliability? This mind map here shows 4 problems with the infusion pump which affects its efficiency and reliability. Firstly, the power supply. For the power supply, there were occasions where where there was an overheating of the battery, spoiled battery, and the fact that there is no backup power source. When the battery of the infusion pump overheats or is spoiled, the whole infusion pump will stop functioning, and this will stop the infusion of the liquid medication into the patient. If the patient is in a critical condition, this may affect the patient and actually threaten their health. The fact that there is no backup power source also affects this, as if the power source is spoiled or is overheated, there'll be no backup power source to help continue the flow of the liquid, which, as I said, will affect the health of the patient. Next is the alarm systems. There have been occasions where there were false alarms occurring. The alarms were not loud enough, and sometimes the alarms do not sound. As for the false alarms, if false alarms keep occurring, nurses or whoever is taking care of the patients will have to constantly check the infusion pump. And if they check the infusion pump and there is no problem with the pump, they have actually wasted a few minutes trying to resolve the problem and actually pause the infusion pump. If the patient is in a critical condition, this may actually affect their health as well, as they are not being pumped the amount they need and is actually being interrupted by these false alarms. For the alarms that are not loud enough or do not sound sometimes, it may actually result in the patient's condition being worse, as they cannot take immediate action as they cannot hear the alarm, and this is very bad for the patient. Thirdly, there's the software and programming errors. So for the software and programming errors, there are problems such as button programming errors and the software errors. As for the button programming errors, if there are errors with programming the buttons, when the users try to set, for example, a delivery rate of 10 ml per hour, and the button programming is wrong and accidentally makes it 100 ml per hour, this may actually lead into an overdose of the fluid medications into the patient and will actually affect the patient negatively, as the patient will be overdosed and further actions may need to be taken. Lastly, the user interface. There are problems such as the fact that some buttons have more than 2 functions, there are no clear labels on the buttons, and it's actually hard to understand the interface. Some interfaces for, let's say, older models, they're actually, the buttons have different functions when you are on different screens. For example, if you're on a screen where you have not decided what delivery rate to set yet, the arrow buttons could be to go up the menu or go down the menu. However, when you're on the delivery set rate, you can actually adjust the delivery rate using those arrows at the same time. For some users, this may actually be problematic as they cannot understand how to do it and they might not be able to use this infusion pump effectively, which may in turn affect the patients negatively. So, what are the recommended solutions? As for the power supply, a backup power source should be added so that in case the first power source melts or has a problem, the backup power source can help continue to run the infusion pump so that the patient can continue being administered the liquid they need. There should also be regular checks and maintenance of the battery to ensure that the battery is not faulty right before an infusion. And if there is a faulty battery right before the infusion, users can actually change the battery before starting the infusion to reduce the chances of an incident happening or any complications. There should also be a low battery warning system to warn users when the battery is low so that they can take immediate action before or after infusing the medication into the patient. Secondly, for the alarm systems, regular maintenance and checks should be made. They should constantly check and test the alarm system by covering the tube, for example, to check whether the alarm system is working properly. This is to ensure that in the event an actual problem occurs during the infusion, the alarm will actually sound properly and is very accurate so that the users can take action immediately. They should also be able to modify settings at which the alarm will sound. For example, if the user wants the alarm to sound when there's a specific dosage of the liquid administered already, this should be possible as it will actually help the user to constantly check whether the fluid has been delivered to the patient. Lastly, there should be distinctive sound for different issues. For example, occlusions and air inline should have distinctive sounds so that depending on the sound, users can take immediate action without having to worry about what is the issue. They already know based on what the sound is. Thirdly, for software and programming, for software and programming issues, regular maintenance and checks for the software should be conducted before and after infusing the patient. This is to check that all the buttons are working properly and the liquid can infuse into the patient at the set rate. There should also be a checklist to ensure that everything is functioning as they should. So before infusing the patient with any liquid, they should actually check that all the functions are working before proceeding with the infusion. Lastly, for the user interface, there should firstly be training programs for users so that those users who use the infusion pump will know how to use it properly and will have no complications when using it. There should also be a more user-friendly design and buttons with maximum of 2 functions per button. This is to ensure that they will not have to keep track of the different screens and when to use which button for the various screens. This will actually help ease the users when they are using the infusion pump and they can understand better. Now, on to the good practices for the design and manufacturing of the infusion pump. For design, the good practices are the safety features implemented, the user-friendly design, the accuracy of the infusion pump, and the durability of the pump. For the safety features, the infusion pump is equipped with sensors and an alarm system, which allows users to take action effective immediately when the alarm is heard. For the user-friendly design, many of the latest models of the infusion pump, the user interface is actually easier to read and operate, which allows users to use the medical device properly and with ease, minimizing the risk of any incidents occurring, such as overdose. As for the accuracy of the infusion pump, it is very accurate with a tolerance of 3% as stated earlier. It is also equipped with a variety of settings for the delivery rate and limit, which allows the user to infuse the required dosage into them without much error. Lastly, for the durability, the infusion pump can be used for a very long time in healthcare places, such as hospitals. For those that require an external power source, its lifeline is longer as it does not rely on battery and can be used for longer periods of time. Now, on to the good manufacturing practices. For regulatory requirements, Standards and regulations were adhered to. Standards such as International Organization for Standardization, also known as ISO, and International Electrotechnical Commission, such as IEC, that apply to the infusion pump were all met and adhered to ensure the safety of the patients and users when using the infusion pump. For the quality management system and essential principles, they must be met by the infusion pump. For those criteria that apply to the medical device, they are met before being put onto the market in order to ensure the safety and well-being of users. Lastly, the documents. All the documents related to the infusion pump should be kept. Important documents such as important details, records, manufacturing processes, design specifications, standard operating procedures, and other relevant documents should be kept to ensure that they are up to date and can be referred to at any point in time when needed. Now, on to the maintenance checklist. Here is a good maintenance checklist that I created, which covers the important things about the infusion pump to take note of when conducting the checks and maintenance of the infusion pump. For example, in the first box, power supply and battery checks. Users should check that the batteries are properly functioning and can withstand the required voltage. They should also check that the backup power supply is properly functioning in the event that the main power supply shuts down so that the liquid can be infused into the patient despite the first power supply being shut down. Secondly, the alarm and detection system tests and checks. Detection systems need to be able to detect occlusions, air bubbles, delivery completion, front door open, and keep vein open. Alarms should also sound when issues such as occlusions and air bubbles are present. Alarms should be loud along with blinking lights to ensure it is noticeable for users to respond to immediately. Thirdly, schedule inspection and maintenance. Regular maintenance should be conducted to ensure the infusion pump is safe to use and is in working condition. Fourth, we have the functionality test. Regular tests should be conducted to ensure that the infusion pump can function properly and deliver the fluids at different rates and volumes with accuracy. Next, we have disinfection of the components. The infusion pump should be regularly disinfected before use, using approved methods to prevent contamination. Next, we have software updates. For the software updates, software should regularly be updated and checked to ensure it's functioning and there are no glitches. This to ensure that when the users are setting the delivery rates and the limits, they are all accurate and does not overdose or underdose the patient. Lastly, we have tubes and connection inspection. Tubes should be inspected to ensure that there are no holes or blockages before infusing the patient. This to ensure that all the required liquid is flowing to the patient at a steady rate and does not result in any complications for the patient. Next, connections between the tube, the patient, and the pump should all be securely connected before infusion. This to ensure that everything flows smoothly and to minimize the risk of any errors occurring, such as occlusion, air bubbles, and etc. Thank you for listening to my presentation.